Okay, previously we have covered on the Cartesian coordinates. So for the next subtopic, we're gonna cover on polar coordinates. Okay, I think most of you already familiar with polar coordinates. You already learned in the engineering mathematics 1, okay, in the previous semester. So when we are talking about polar coordinates, we are talking about the point or the coordinates in terms of r and theta, if you guys still remember. So basically, why we're going to use polar coordinates in double integral. So we're going to use polar coordinate when the region is a circle. So basically, use polar for circle region is much more easier compared to Cartesian coordinates. Okay, so let's take a look at the definition of polar coordinate system. So basically, this one is the revision on whatever that you have learned in the previous subject. Okay, so this one, okay, for polar coordinate useful for region R in circular type. Okay, x squared plus y squared equal to whatsoever given. Okay, so basically R is basically radial coordinates and theta represent the polar angle. Okay, so this is what you have learned in the previous. Okay, so this is just a revision. Okay, how to convert from Cartesian to polar coordinates. So y equal to r sin theta, x equal to r cos theta, and how to get the what we call polar angle. Okay, equal to inverse tangent y over x. So basically, this one is just the revision on how to convert from Cartesian to polar coordinates. Okay, so so this is the shape of curve in polar equation. Okay, so basically this kind of shape, how to get the shape, you already learned in the previous subject. So this is the list of the shape of curve that you already learned. Okay, this one, the general form, how to get this one. Okay, so this is cardioid, lemniscate, rose petal. Okay, so basically, how can we integrate, okay, from Cartesian to polar? Okay, so if we take a look, okay, previously we have we have previously for Cartesian. Okay, Cartesian. So dA basically represent dx dy or dy dx, right? So for polar, so dA is basically represent r dr d theta. Okay, so from Cartesian we can convert into polar coordinates. Okay, so don't forget we have r here. Okay, r dr d theta. So this limit represent for the angle. So limit for theta must be constant or fixed. Okay, so by Fubini's theorem, we can also interchange the order, but most likely in our syllabus we only focusing on the first type. Okay, it's a rare cases if we ask student to interchange the order in polar coordinate. We usually use r dr d theta. Okay, but it can be convert, but most likely the question will ask in terms of r dr d theta. Okay, so how to determine the limit? There's two things that you should always remember: that the angle move anti-clockwise, okay, and r measured from the pole, okay, from the origin. Okay, so okay, so take note on common polar equation. So if we have this kind of circle, so obviously we're gonna know the r, right? R basically represent the radius. So if we have this kind of shape, what is the values of r? So if we have this shape on y-axis, so this is the value of r. Okay, the idea of this one basically come from all the shape that you already learned previously in the engineering mathematics 1. Okay, So let's take a look at this one. Okay, so let's say if I give you this kind of region, okay, what is the limit? So we know that the radius is 2, right, from here to here. So the radius is between 0 to 2. Okay, so what about the angle? Okay, so this is in anti-clockwise direction, right? So it's going to start from here up to here. So from 0 up to pi over 2. So that's why the limit it will be like this. Okay, so this one represent for the theta, this one represent for r. Okay, what about in these cases? So the radius or the value of r still same, right? 0 up to 2 here. Okay, but what about the angle here? The angle is anti-clockwise, right? Let's start from here up to here. Okay, so let's start from pi over 2 up to pi here. So that's why the angle change from pi over 2 up to pi. Okay, because of the location of the shaded region. This one is in the first quadrant, this one in the second quadrant. Okay, so you can practice. How can we get the limits for this shape, and this shape? Okay, if you understand very well how to get the limit for this particular region, you can always get the limit for this region too. Okay, so let's take a look for example 1. Okay, so evaluate where R is the region inside the circle, x squared plus y squared equal to 4. Okay, so the idea to answer this question basically depends on the region. So obviously stated that the region inside the circle, so it's much more easier if we use polar coordinates. Okay, so in these cases, so we should sketch first. Okay, the step in answering for double integral, basically start with the sketches and then get the limits, and then you can integrate as long as you get the limit correctly. Okay, so x squared plus y squared equal to 4. Okay, in these cases, please make sure that you know that r in these cases is 2, right? Okay, so we're going to get a circle like this. Okay, so the given that x squared plus y squared plus 1. So we're going to change this one into polar coordinates. So we know that x equal to r cos theta. So y equal to r sin theta. So let's take a look at this one. Okay, so after, okay, let me clean this one first. Okay, this one. Let's take a look. Okay, how to change this one? So x squared plus y squared plus 1, right? So x is equal to r cos theta squared plus r sin theta squared plus 1. So if we simplify this one, we're gonna get r squared cos squared theta plus sin squared theta plus 1. So I hope you guys still remember the identity. So this one is equal to 1, right? So that's why we have r squared plus 1 here. So that's why after we convert, we have r squared plus 1 here. Okay, so dA in polar coordinates is equal to r dr d theta. Okay, how can we get the limits? So for r, okay, it's obviously 0 to 2. Okay, 0 to 2 here. Okay, what about the angle? Okay, they obviously stated that the region inside the circle. So obviously 0 up to 2 pi, the whole circle. Okay, after you successfully convert into polar coordinates, you can just simply integrate and then you will get the answer. Okay, I think the idea on how to solve for Cartesian or polar coordinate is still same. Okay, we start with the sketch the region first, and then decide the shaded region like this, and then just the extra step for polar coordinate is basically how to change from Cartesian to polar. Okay, after that you can just simply integrate and then you get the answer. Okay, so for the second example, I think this one is quite similar. Okay, but the shaded region is much more complex compared to the first one. So the region bounded by circle each centered at the origin with radius is 1 and 2. So basically we can say that we have two circles here. Okay, so we're gonna find which is the shaded region involved to answer the question. Okay. Okay, so they obviously said that the region bounded by circle each centered at the origin with radius 1 and 2. Okay, so let me clean this one. So means that we're gonna have two circle. Okay, so x square plus y square equal to 1 root of 2, and the other one is x square plus y square equal to root of 2. Okay, so we're gonna have two circle. Okay, so we're gonna have two circle. So basically the bounded region between these two circle is represented with this one. Okay, if we take a look at this one, the bounded region is somewhere that we shade here. Okay, so from this one, 1 over 1 plus x squared plus y squared, I think this one is quite similar to the previous question, so we're gonna get this one. Okay, the idea for limit is quite different here. So since this one start with r equal to 1, right, up to r equal to 2, so that's why the r here change from 1 to 2. The angle is still same because we take the whole, right? Start from here. Okay, so like this, right? So let's say we have this, I'm sorry. Okay, so let's say we have a circle here. Okay, we have a circle like this. Okay, we have oh my god, two circle. Okay, so x and y here. Okay, so we must remember that the angle is to move this one, right, anti-clockwise. So it start from here up to here. So the shaded region will be in this one because it's bounded region between two circle, right? Okay, I know it's very bad sketching. Okay, so that's why the angle is 0 up to 2 pi. Okay, so this one, so the first circle here. Okay, so this one is r equal to 1, right? So this one r equal to 2. Okay, since the shaded region that we considered is from here up to here, so that's why we have here 1 to 2. Okay, after that we can just simply integrate and we will get the answer. Okay, make sure that you try to solve the question by your own. Okay, I will provide the example of question from tutorial in the WhatsApp group after I give you the video. Okay, thank you.